So in this problem we're told to evaluate the indefinite integral use c for the constant of integration, and we're given the integral of 4 plus 5x over 1 plus x squared dx. So we're using U substitution, but what we want to do first is simplify this integral. And so the way we're going to do that is by splitting this into two different integrals. So here's my first integral, and here's my second one. So what we're going to do is we're going to add them together, right? So you can split this integral into 4 over 1 plus x squared, right? And then the other one's going to be 5x over 1 plus x squared. And then dx for both of these. And so what this did was we can solve this integral without U substitution, and then we're going to use U substitution to solve this one. So yeah, so just split your integrals into two, and then now we're going to solve. Let's start with this one that we can solve without U substitution. So what you should recognize is that this is the same thing as, this inside is the same thing as 4 times 1 over 1 plus x squared. And if that seems familiar, well, the derivative of the arctangent of x is equal to 1 over 1 plus x squared. So that means the antiderivative is arctangent of x for this one, and then we're just multiplying by 4, right? So it's just going to become 4 times the arctangent of x, then plus c, right? So that's this integral solved. And then we're adding this whole thing to the integral, or this solved, right? So this one we actually do have to use U substitution. So let's decide what we're going to use to make U. And what should jump out at you is that if we take the integral, or the derivative of this, it would become 2x, and that could cancel with the top. So that's what we're going to do. So we're going to set u equal to 1 plus x squared. Then let's take the derivative of it. So derivative of 1 is 0, derivative of x squared is 2x. Then we have dx, right? And then what we got to do is solve for dx. So we divide both sides by 2x. It'll give us that dx equals du over 2x. So now we want to rewrite our integral, right? And so our integral is like this. So what we want to do is write 5x, and then replace our 1 plus x squared with u, right? Because that's what we set u equal to. And then we multiply by dx, right? But we're going to replace dx with what we solved dx to be, so du over 2x. Then what you should see is that our x's will cancel, and then we just have this 1 half, right? Because this is basically 1 half. Put out front, multiply by 5, so 5 over 2. So this thing will basically just simplify to 5 over 2 times 1 over u du. So now we've got it like this. All we got to do is take the antiderivative. And so the antiderivative over inside, well, we know the derivative of the ln of u is 1 over u, right? So the antiderivative is basically the same thing, except for it has absolute value signs. So the antiderivative of this is just going to be 5 over 2 times ln of the absolute value of u, then plus c, right? Because we're taking antiderivative. So that's going to be the answer to this integral, right? So we solved it. Then we got to add it to this one. So if we add them up, we're going to get 5 over 2 times the ln of the absolute value of u. And then our c's are going to combine basically. So I'm just going to add this part next. So plus 4 times the arctangent of x. And then our c's combine, right? So we'll just add them at the end. So now we got it like this. All we got to do is replace u with what we solved u to be, which is 1 plus x squared. So our final answer is going to become 5 over 2 times the ln of the absolute value of 1 plus x squared, then plus 4 times the arctangent of x plus c. So this right here is going to be our final answer.